Back, my dear future stars of Max and my viewers and my subscribers. I'd like to thank all my viewers, those who are watching my videos, and I request the new viewers to please subscribe to my channel Future Stars of Max. Okay? Today let's do our sixth sum of exercise 11.1, which is very important. Okay, so listen very carefully, students. Now we'll read the question. In triangle ABC and triangle XYZ, if angle A and angle X are acute angles such that cos A equal to cos X, then show that angle A equal to angle X. Okay, so whatever is given, we'll do write that first. Here it's given that cos A equal to cos X and angle and A and X are acute. So we have drawn two right angle triangles. Okay, here 90 degrees is at B. So the side opposite to this will be the hypotenuse side. And if we take a angle at A, then the opposite side to this will be this opposite, and this is the adjacent side. Similarly, here is 90 degrees. So the side opposite to 90 degrees is hypotenuse. And if we take theta here, that is at X, then the side opposite to it is the opposite side. And the side adjacent to it is the adjacent side. Okay, so from these two triangles, what we have to find? Cos A and cos X. So from this triangle, we can write what is cos A. So what will cos A be, students? You all know it is adjacent by hypotenuse. So what is adjacent side here? AB by what is hypotenuse? AC. Similarly, from this triangle we can write what is cos x. Okay, so what will be cos x? Same thing, the adjacent side by the hypotenuse side. So it is equal to xy by xz. What is given? Cos A equal to cos x is given. So what we can do? We can equate this two since it is given. Okay, cos A equal to cos x is given. So what we can write? AB by AC equal to what is cos x? Xy by xz. Let this be first equation. Okay, which we got. We'll use this later on. Here also we are going to use, but this equation again we have to use in the at the last. So we are equating this as first equation. Okay. Now, since these both are equal, what we can do? We can equate this as let AB by AC equal to xy by xz equal to some constant k. Okay, so from this what we can write? AB by AC equal to k implies AB equal to, when we cross multiply, that is when we shift AC here, what happens? It will be multiplied in the numerator here. From denominator it will go to numerator, KAC. So this is our second equation. Similarly, what is xz? Xy by xz equal to k is given. So we can find the value of xy equal to k into xz. This will be equation 3. Okay, is it clear till here? Now you observe this triangle, students. Here the adjacent side and the hypotenuse side we have used, but we didn't see this opposite side. Okay, so what will be this opposite side equal to? How can we get this? By using our Pythagoras theorem. Okay, by using Pythagoras theorem, we can write that the hypotenuse square is equal to opposite square plus adjacent square. So what is hypotenuse? AC square equal to opposite side. It is what? BC square plus adjacent side is AB square. Okay. So now what we have to do? We have to find the value of what? BC. Okay. So AB is extra. So we will shift this AB to the other side. So what it becomes? BC square equal to AC square plus AB square. When it shifts to other side, it becomes minus AB square. Okay. So this is equal to BC square is equal to AC square minus, but what is AB square? We got the value of AB square as K into AC. So we will use this here. Okay. K into AC whole square. How we are getting this? From equation 2. Okay. So now whole square is there. So this square gets inside the bracket. So it will become BC square is equal to AC square minus K square into AC square. Here also we have AC square. Here also we have AC square. So we will take AC square common. Okay. Why to write 2 times? We will write only 1 time. This is called common. Okay. So when AC square is odd, what is remained? Nothing is there. That means it can be multiplied by 1. So what we will get? AC square goes out and 1 remains in the bracket. Then minus AC square goes out. So what is remained here? K square. Okay. Now this square will shift to other side. So it becomes square root AC square into 1 minus K square. Here root is for both the things. Okay. So we will separate the root here. So root AC square into root 1 minus K square. If here whole square is there, then we will take for whole square. Okay. But here K square is inside the bracket. It is not outside. So this square and this square root doesn't cancel out. Okay. But here we have a square root and a square here. So here this will get cancelled. Okay. So this will be equal to AC root 1 minus K square. Okay. So similarly we can find the YZ side also. Okay. In the same, you have to follow the same procedure. Okay. So we'll do it here. Hypotenuse square is equal to opposite plus adjacent. So here what is hypotenuse square? Hypotenuse side is xz. So xz square is equal to opposite side is yz plus adjacent we don't know. It is it's given xy square. We are going to find what? The opposite side. So we will shift this xy square here. So yz square is equal to xz square minus xy square. So yz square equal to xz square minus, from equation 3, what do we have? Xy is equal to k into xz. So we will substitute that here. K into xz whole square. Again this square gets inside the bracket. So it becomes k square into xz square. Again here what do we have? Xz square as common. So what is left? Here 1 minus here k square. So yz equal to square root of xz square into 1 minus k square. Then we have to separate this root. Root 1 minus k square. Square and root get cancelled and we get the value of yz as xz into root 1 minus k square. Okay students, is it clear till here? Now let this equation be the fourth equation and this equation be fifth equation. So when we divide equation 4 by equation 5, what we are going to get, see students? BC by YZ. So what is BC? AC into root 1 minus k square by what is YZ? It is XZ into root 1 minus k square. Here root 1 minus k square is there. Here also we have the same thing. And in between into is there. So we can cancel this. If here plus is there and same thing is in numerator and denominator, we cannot cancel. If there is a multiplication sign, then only we can cancel this. Okay, remember this. Then what we are getting, it is equal to AC by XZ. But what is AC by XZ according to equation 1? Here from 1 we will derive this, what it will be. Okay, from 1, what is equation 1? AB by AC equal to XY by XZ. So we will interchange this. We will send this numerator to this side and the denominator to this side and the numerator to this side. Okay, so what it becomes? AB by XY is equal to this AC shifts here. So it will become AC by XZ. But what we got AC by XZ as BC by YZ. So we can write that it is equal to BC by YZ from here. Okay, so what are these? When you see the triangles, you can see that AB by XY. What is AB by XY? It is the corresponding sides of two triangles. Okay, AB by XY. Then AC by XZ, it is the hypotenuse sides, the ratio of the hypotenuse side. And BC by YZ, it is the ratio of the opposite sides. So all these are equal. What does it mean? That both the triangles, that is ABC and the triangle XYZ are congruent. Then what happens if the corresponding sides are equal? What happens? The corresponding angles also become equal. So what we can write? Therefore angle A equal to angle X. Okay. The same type of sum is there in examples using sine. You can see that and do the sum. Okay. Thank you.